Welcome all. This is lecture number 9. In this lecture, we will discuss Green's theorem in the plane. So this is also the part of vector integration. So what is Green theorem? If capital C is a regular closed curve in the xy plane and capital R be the region bounded by the curve C, then integral C m dx plus n dy equals to double integral R del capital N over del x minus del capital M over del y dx dy. So we can say this is just like the line integral is converted into the double integral. So we can say this is the relation between line integral and single integral and double integral, where capital M xy and capital N xy are continuously differentiable function inside and on the curve C. Area of the plane region by Green's theorem. So area can be defined as 1 by 2 integral C x dy minus y dx. Example 1. Using Green's theorem, evaluate integral C x square y dx plus x square dy, where C is the boundary described counterclockwise of the triangle with vertices 0, 0, 1, 0 and 1, 1. So to solve it, we first draw a triangle whose vertices are given. So let this is the x-axis and this is the y-axis. Now O 0, 0 means the origin O, 1, 0 is at the x-axis at this particular place, let it is A, and 1, 1 lie in the xy plane. Suppose this is the point B. So joining AB and OB. So this is the triangle for which we have to evaluate this particular expression. So from Green's theorem we have integral C m dx plus n dy equals to double integral R del n over del x minus del m over del y dx dy. So from when we compare this with this left hand side, we get capital M equals to x square y and capital N is equals to x square. So del n over del x is equals to 2x and del m over del y is equals to x square. So on putting these in the right hand side, we get 2x minus x square dx dy. Now for the limits, now we have to solve it. So for the limit, we have to draw a strip either parallel to x-axis or parallel to y-axis. So when we draw a strip parallel to y-axis, so let this is the strip. So at this particular strip, here it is y equals to 0 and at this particular point y equals to x, and the limit for x are initial limit is 0 and the final limit is 1. So the limit for x are 0 to 1 and the limit for y are 0 to x. So on replacing the limits, we get integral x equals to 0 to 1, integral y equals to 0 to x, 2x minus x square dy dx. So first we have to integrate it with respect to y. So for the y, this 2x minus x square, it is treated as the constant. So we can take it outside this integral. So just like this, so it is the integral y equals to 0 to x dy dx. So the integral of dy is y under the limit 0 to x. So when we put a limit, then it will convert into x. So integral x equals to 0 to 1 2x minus x square into x dx. Now we can solve it directly, but before integrating we have to multiply this x inside the bracket. So it will convert into 2x square minus x cube. So what is the integral of x square? The integral of x square is x cube by 3, and the integral of x cube is x raised to power 4 by 4 under the limit 0 to 1. So on replacing the limits, we get 2 into 1 by 3 minus 1 by 4. So taking LCM, 3 and 4, LCM as 12. So when we multiply this 4 to this 2 1 ja 2, so 2 4 ja 8 and minus 3. So it will be 5 by 12. So this is the required solution of the given expression. Example 2. Verify Green's theorem in the plane circular integral 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the boundary of the region bounded by x is greater than equals to 0, y is less than equals to 0, and 2x minus 3y equals to 6. So to solve it, we first draw this particular region. So let this is the x-axis and this is y-axis. Now see, x is greater than equals to 0. So it means y-axis, and y is less than equals to 0. So it means x-axis. Y is less than 0, so x-axis in the downside. X is greater than equals to 0, that is the y-axis in the right hand side. So this particular region, basically now we have to draw this particular line. So this is basically a straight line. So to draw it, we have to find the boundary points. So how to get the boundary points? When we put x equals to 0, then y is equals to minus 2. So the point is 0 minus 2. Let it is A. And when we put y equals to 0, then x is equals to 3. So it is 3 0. Let this is the point B. Now if we join this A and B, then we can get this particular line. So joining this, now see, what is the coordinate of O? O is the origin, so the coordinates are 0 0. Now according to Green's theorem, this is the relation between single integral and double integral. So single integral means this may be the line integral. So this can be solved as just like the line integral. So for the line integral, it walk along the lines either clockwise or the counter clockwise. So OA, AB and BO. So from Green's theorem, we have the standard formula this: integral C m dx plus n dy is equals to double integral R del n over del x minus del m over del y dx dy. So on comparing this LHS with the given problem, we get capital M equals to 3x square minus 8y square, and capital N is equals to 4y minus 6xy. So we first take LHS. So integral, the LHS is the line integral. So we can define it as integral m dx plus n dy for this line OA plus for this line AB and plus for this line BO. So at this particular line OA, this is the y-axis. So at this particular line, it is x equals to 0. So at this particular point, x equals to 0, so dx is also equals to 0. At this particular AB, we can get x equals to 1 by 2 time of 6 plus 3y. So that dx is equals to 3 by 2 dy. And this is the x-axis. So at this particular point y equals to 0, so that dy is also equals to 0. So this is the first case OA. In this case x equals to 0 and dx is equals to 0, and the limit for y are 0 to -2. So keeping all these things, we write this OA in this particular manner, that is x equals to 0, dx is equals to 0. So this entire term is 0. Here this 6xy is also 0, so only 4y dy remains, and limits are 0 to -2. Now moving on to the second part AB. At this particular point, limits for x are 0 to 3, and the x is equals to 1 by 2 time of 6 plus 3y, so that dx is 3 by 2 dy. So on replacing this 3, x is replaced by 1 by 2 of 6 plus 3y, 8y square as it is, and the value of dx is 3 by 2 dy, plus 4y as it is, minus 6 time of this 1 by 2 of 6 plus 3y, and into y as it is, and dy is also as it is. Now see, this 2 is cancelled out by this 3, this 6. So this will be 3, and this 2 will convert into 4 because 2 square is 4. And when we multiply this 3 by 2 inside, then this 8 will convert into 4. And 4 3 ja 12. And this third one, BO. For the BO, y is equals to 0 and dy is also equals to 0. So on putting here, this entire term is 0. This 8y square is also 0. So only 3x square dx remains, and the limit for x are 3 to 0. So now this 4y will convert into twice of y square under the limit 0 to 2, plus this will be, now we can take 3 outside this bracket, so it will be 3 square. 3 square will be 9, and 9 3 ja 27, and this 3 also in multiplication, so it will be 81 upon 2 square is 4 and 4 2 ja 8. So it is 2 plus y whole square remains, minus 4 3 ja 12 y square as it is, plus this will be 6 3 ja 18 y. This is 4y minus 18y, so it will be minus 14y, and minus 3 3 ja 9y square. So taking minus outside, so this is plus 9y square dy. Now what we can do here, first the integral of 3x square is 3x cube by 3 under the limit 3 to 0. So this 3 is cancelled out. Now this will be 4 to ja 8, and it is the integral of 2 plus y whole square is 2 plus y whole cube upon 3 into coefficient of y, which is 1, minus integral of y square is y cube by 3, minus 14 time of integral of y is y square by 2, and minus integral of y square is y cube by 3. So now see, this 3 cancelled 81 27 time. This 3 cancelled this 12 4 time. This 2 cancelled this 14 7 time, and this 3 cancelled this 9 3 times. And the last one is the 0 minus 27. So now 2 4 ja 8, plus this is 27 by 8 into 2 cube, because when we put 0 then this is 2 cube, and when we put minus 2 then this will be 0. So only 2 cube remains. This is minus 4, and when we put 0 then it is 0, and when we put minus 2 and already minus, so minus minus plus, so it will be minus 2 cube. Same as this will be plus 7 minus 2 square, and this will be plus 3 minus 2 cube, and this is minus 27. So 2 cube is 8, so 8 is cancelled out by this denominator 8, and now 8 minus 27 is minus 90. This is 27 minus 8 4 ja 32, minus 2 square is 4, 4 7 ja 28, minus 2 cube is minus 8, 3 ja minus 24. So on simplification we get it is minus 20. Let it is equation number 1. Now moving on to the right hand side. So right hand side is double integral r del n over del x minus del m over del y dx dy. So n is 4y minus 6xy and m is 3x square minus 8y square. So on differentiating partially this particular function with respect to x, then 4y is 0 and it is minus 6y only remains. And here when we differentiate partially this 3x square with respect to y, then it is 0, and this minus 8y square with y, then it will be minus 16y. So it is equals to minus 6y plus 16y dx dy, or we can write it as 10y dx dy. Now we have to find the limit for this particular double integral. So again, taking the figure, so now we draw this particular strip. So at this particular strip, this is parallel to y axis. So when it is parallel to y axis, so the variable limits for y. So at this particular point, y is equals to 1 by 3 of 2x minus 6, and this is the x axis. So at this particular point, y equals to 0. So the limit for y are 1 by 3 2x minus 6 to y equals to 0, and the limit for x 0 to 3. So we can write it as 10 outside. Integral x equals to 0 to 3 because it is the constant. So we can take it outside. Integral y equals to 1 by 3 2x minus 6 to 0 y dy dx. So first we integrated with respect to y. So the integral of y is y square by 2 under this particular limit. So when we put a 0 then it is 0, and when we put this then it will be, now see, when we put this particular limit, to minus arises, so minus here 10 or by 2, that is the 5. We can cancel out this directly. To cancel this 10 5 times, so this is that particular 5. Now when we put this particular 2x minus 6 by 3 whole square, then 3 square is 9. So right here, and this is 2x minus 6 whole square dx. Or we can take this 2 outside it, or we can directly integrate it. So the integral of 2x minus 6 whole square is 2x minus 6 whole cube upon 3 into coefficient of x is 2 under the limit 0 to 3. So on putting the limits, we get minus 5 by 9 as it is. When we put 3, then 3 to just 6 minus 6, it is 0. And when we put 0, then it is minus 6 cube upon 6. So minus 6 cube is minus 216, and already minus there, so plus 216 divided by 6, so it is 36. And now from 9 we can divide this 36 4 times. So 5 4 ja 20 and minus is already there. So this is equation number 2. Now see, from the equation number 1 it is minus 20, and from the equation number 2 it is also minus 20. So the value arises from the both method are same. So from equation 1 and 2 we can say integral c m dx plus n dy is equals to double integral r del n over del x minus del m over del y dx dy, which is equals to minus 20. So Green theorem verified. Hope you understand it. Now example number 3. Using Green's theorem, find the area of the region bounded by the curve y equals to x, y equals to 1 upon x, and y equals to x by 4. So to solve it, we first draw these curves. So let this is x-axis and it is y-axis. So y equals to x is a straight line passing through origin at 45-degree angle, just like this. This is y equals to x, and y equals to x by 4 is also the straight line. So we can draw it here. This is y equals to x by 4, and y equals to 1 by x is a curve. This. So now let this is A and this is B. So the coordinate, find the coordinate of A and B and O. O is the origin, so the coordinates are 0 0. When we find A, then for this we have to solve this y equals to 1 upon x and y equals to x by 4. So from here x square is equals to 4 or x equals to plus minus 2, but it is in the first quadrant, so x equals to 2, and when x equals to 2 then y equals to 1 by 2. So the coordinate of A are 2 and 1 by 2. And now when we solve y equals to x and y equals to 1 by x, then the coordinate of B are 1 1. So from Green's theorem, area of the region is area equals to 1 by 2 circular integral C x dy minus y dx. This is the standard formula. So this is the line integral. So we can write it in term of these three lines, two line and one curve. That is, area can be write as 1 by 2 outside circular integral for OA plus 4AB plus 4B. Now see, for OA, y equals to x by 4. So dx is equals to 1 by 4 dx, and the limit for x are 0 to 2. For AB, y equals to 1 by x. So dy is equals to minus 1 upon x square dx, and the limits for x are 2 to 1. And for BO, it is y equals to x. So dy is equals to dx, and the limits of x are 1 to 0. So on putting all these here, we get area equals to 1 by 2 of, for the OA, limits are 0 to 2, x into value of dy is 1 by 4 dx minus value of y is x by 4 dx plus for AB, x as it is, value of dy is minus 1 upon x square dx minus value of y is 1 upon x dx, and plus for BO, limits are 1 to 0. Well, x, the value of dy is dx and the value of y is x. So x dx minus x dx. Now see, this is x by 4 and this is also x by 4. So the entire function is cancelled out. Here this one power is cancelled by this x, and here x dx and x dx both are 0. So in the first case 1 by 2 outside, this is all are cancelled out, so this will be 0. This is minus 1 by x and minus 1 by x, so it is minus 2 by x, so we can take minus 2 outside. So integral 2 to 1 1 by x dx, and this all are cancelled out, so it will be 0. So now integral of 1 by x is log x under the limit 2 to 0, and this 2 is cancelled by this outside 1 by 2. So when we put limit, this limit is 1. So when we put a limit log 1 minus log 2, minus is already there, so it will be plus, and log 1 is 0, so it is only the log 2. So this is the required area for the given region. Hope you enjoyed this entire content of the vector calculus, which conclude in the 9 lectures, which contains vector differentiation and vector integration. Thank you.